This video will go through Pythagorean inequalities. So previously we figured out that Pythagorean theorem helps us solve for missing sides of right triangles. But Pythagorean inequalities can help us determine what type of triangle it is based on the side lengths. So there's a relationship between the length of the two shortest sides of a triangle and the length of its longest side. So if it's an acute triangle, c squared is going to be less than a squared plus b squared. If it's obtuse, c squared will be greater than a squared plus b squared. And if it's right, c squared will equal a squared plus b squared. Just like in Pythagorean theorem, we call the short sides a and b and the long side of the triangle c. Before you do any example, you always need to double check that the side lengths can actually create a triangle. I also like to personally put mine in order from smallest to largest. So this would really be 5, 7, 10, and then I just label them A, B, C. So first I need to check, is it a triangle? So quickly double checking that. Is 5 plus 7 greater than 10? Yes. Is 7 plus 10 greater than 5? Yes. Is 10 plus 5 greater than 7? Yes. So yes, this is a triangle. After that, you can set up your Pythagorean inequality. So on the left side, we're going to have c squared. I like to just leave a blank here. And then I have a squared plus b squared. So this would be 100, 25, and 49. And then 25 plus 49 is 74. So if I fill in this blank with less than, greater than, or equal to, I'm going to get greater than, which makes this triangle obtuse. For this next one, again, I want to check, is it a triangle before I do anything else? I also like to make sure that the sides are in order from smallest to largest, and they are. So is 3 plus 4 greater than 8? And the answer is no. So this is not even a triangle. So at this point, our answer is not a triangle. For this next one, they're 4, 4, and 4, so they are in order from largest to smallest. Is it a triangle? Hopefully you already know the answer is yes, because 4, 4, and 4 would be equilateral. But if you want to double check, 4 plus 4 is greater than 4, and no matter how I rearrange those, it's always going to be the same thing. So yes, this is a triangle. So then I'm going to label them A, B, and C. I put c squared on the left. I put a squared plus b squared on the right. And I leave a little blank here for my inequality. So this is going to be 16, 16, and 16. 16 plus 16 is 32. And from here I'm deciding, is 16 less than, equal to, or greater than 32? And it's less than, which makes it acute. And in our last example, I'm going to double check that they're in order from smallest to largest, which they are. I'm going to double check, is this a triangle? So 3 plus 4, is that greater than 5? Yes. 4 plus 5, is that greater than 3? Yes. 5 plus 3, is that greater than 4? Yes. So this is a triangle. Again, C has to be the largest side, so I'm going to put that on the left, so 5 squared. And then a squared plus b squared would be 3 squared plus 4 squared. I'm leaving a little space here for my inequality symbol at the end. 5 squared is 25, 3 squared is 9, 4 squared is 16. When I add 9 plus 16, I get 25, and then I'm filling in, is 25 less than 25, greater than 25, or equal to 25? And since these are equal, that makes this a right triangle.